This is another episode of the Mario in SFML series, and in this video we are going to create a map for our Mario game so that we can have actual ground instead of just an empty screen with a Mario. So we want to add like ground and stuff. So for this I have created a ground tile here that I have called block.png, and I have imported that into my Visual Studio, and it's in the resource files. And you can see here that this is what it looks like. If I turn off the grid, you'll be able to see it better. So yeah, this is just the standard Mario tile that is used in Mario games. So with that done, I have actually done a couple of things already. So first of all, I have created a class called map with a file called map.h and map.cpp. We will get to that in a second. First of all, let's discuss what the changes in the main file. In the main.cpp, I have gone ahead and said hashtag include map.h, and in here this I basically created a map called map, which is going to be the main map. And since this is a class, we can create actually multiple maps we want to and switch between them really easily. So when we are doing the character pushing, we also use a method on the map called create dummy map. Now this method essentially creates a map with just a floor and nothing else. And basically you've got so this is like saying 30 here. So you have basically got this is the length of the map, so how many the map has got. So this for example, for the height, the map is always going to be fixed, so the height is always going to be equal to the screen, but the width of the map may be different, and this is basically specifying the width of the map. And after that, the only other change I have made is that here, before we draw the characters, remember before, because the map needs to be drawn behind every important thing, we are saying map.draw window. And the map.draw is a method on map which we will come to in a second, and window is basically the window which we are passing to it because it needs that as an argument. And this is done before we draw any of the characters like player and enemies and stuff. So now let's go ahead and go under map.h, and in here what you should see is that I have included a bunch of stuff here. We will discuss this in a second as we go along. So we have got a type def here, and we will come to discuss this type set when we get to this. So first of all, let's discuss map. So this is class map, and got a couple of public functions and a couple of private variables. So for the functions, we have got three of these. So the first one is map, and this is the constructor, so just the constructor here. The second one is the create dummy map, which takes an int called length. We just talked about this in a second, talked about it a second earlier. And this is another void called draw, and it obviously takes the render window, and this is going to draw the map. Now we will discuss the implementation when we get to map.cpp. For now, let's look at the variables. So in here we have got a three private variables. So first of all, the std is a std colon vector. So this is a vector because the length of the map can be different, of type column. Now what is this type column? If I go up here, a column is, we are using a type def to define it, which basically means that this type is this saying column is equivalent to saying this. This basically means this. So it's an because this is very long, I just made it column so that it's a bit easier to write. So a column is essentially an std colon array, and remember these two are completely equivalent. We can use whatever they want. You can use a column just like you use an array. So it's a type something of type std colon array, and this is a of type boolean, so an array of booleans, or true or false values, an array of that, and the size is equal to height by cell size. And if I go under my global.h file, you can see I've added a new constant here called cell size, which is 30. This is basically defines how large a cell or a tile is, and we divide that by height. We divide that by cell.size to find out how many cells should we have to fill all the way from top to bottom of the screen. And now I'm going to go under my class map, and in here we have got we have already discussed this. So now let's go back to this here, and we have got a sf colon texture here called texture, and an sf colon sprite here called sprite. And we will discuss the function of these two in a second as well when we go to map.cpp. So let's go here, and in here first of all you will see that we have got a map colon map constructor. So the first thing is that we are doing the setting of the texture and sprite, which we are going to use to draw the stuff, draw all of the tiles onto the screen, all of the cells. So first of all, we have got texture.load from file block.png, which I just showed you. So we are just loading the texture from the file, and then we are setting we are calling the constructor on the sprite, or you don't really need to call the constructor. You can just say sprite.set texture as well. So just say set texture and texture, and that will work just as well, and pretty awesome. So in here we have got set scale here, and for the set scale we are doing a bunch of calculation here. Firstly, we are converting that cell size to a double so that it takes into account floating point values, or else it won't work correctly. And I am basically dividing this by texture dot get size dot x, which basically is like, making sure, because this is the scale, not the absolute size. We need to set the scale relative to the amount of pixel already contained. So we just basically divide this by the amount of pixels so that we get a size that is exactly equal to the cell size variable. And we do the similar thing for the y-axis, and we did this also when we were creating the Mario sprite. So now let's go to the create dummy map function. Now this is basically just a for loop in which we go for like amount of length, so whatever length we've got, we loop for that time, and we create a column C, which is just equal to a new column basically with a constructor. And you call the constructor, it's kind of necessary because else it might not set every value to false, because we want every value to be false, and we'll discuss that in a second as well. So what basically we get the c dot size -1, which means the last value of the array will be set to true, which means that the end the floor one will be true. And then we go ahead and say map dot push underscore back c, and map is, remember, the main vector, so we push the array to it, because map can be added and removed element from it. So now let's go to map to colon draw here, and we take a window obviously here, because you need to do that for drawing. And we create a variable called int x is equal to 0, and then we go ahead and run a for loop, which is like a for each loop. So we have got loop over map with each column, and then we go ahead and create a variable called int y is equal to 0. And for that we again do all of that, which means we create a for each boolean of which we are going to call draw in column. What we do is that if that draw variable is true, so this is basically telling whether we draw a cell or not, and if that draw is true, then what we do is we go ahead and sprite dot set position, we set it to x multiply cell underscore size and y multiply cell underscore size, and this x will basically help us get the position. So we get the position. If it's 0, then it will be at the top left corner, then it will move by intervals of cell size so that it's always at the right position. And then we go ahead and window dot draw sprite. So in this way we can use one sprite to draw all of the columns. So that's pretty awesome. And we obviously increase the y, increment the y here, and increment the x here. Now that is pretty awesome, and this is basically how our whole map drawing function works. So if I start, what you should see is that our map is working absolutely correctly. So as soon as it starts, let's go ahead and see. You can see that we have got a row of cells down there. But obviously currently there is no like collision detection, which we will implement in the future videos, but the basic idea is working. So yes, this is pretty much it for this video. I will see you in the next one, in which we will go ahead and try to implement collision detection. That's my plan. So stay tuned for that. I will see you in the next one. Make sure to like and subscribe as well, and bye.